Hey guys, tonight we're going to start with something that's always been right above you, night after night, and yet, you probably haven't really looked at it in a long time. The moon. Not the romantic version, not the poetic muse. Just that round, quiet, glowing rock that seems to follow you home every night. You might think it's always just there. Fixed. Reliable. But what if I told you it's leaving? Slowly. Silently. And there's nothing we can do to stop it. The moon doesn't make a scene. It doesn't roar through the sky or flicker with color. It just hangs there, softly lit, always in the same general spot, always at the edge of your awareness. You don't check on it like you do your phone, you don't wonder where it goes during the day, and if it's missing one night, clouded out, you don't panic. It's just the moon. But the moon is moving. Every year, it drifts away from us by about 3.8 centimeters. That's about as fast as your fingernails grow. Not enough to notice. Not enough to cause alarm. But in cosmic terms, it's a quiet revolution in slow motion. If you've ever stared up at it and felt that strange comfort, that no matter what's going on in your life, that cold gray "I will still be watching the earth tonight," you're not alone. Humans have depended on that consistency for tens of thousands of years. But here's the unsettling part, that consistency is an illusion. The moon didn't always look like this. It wasn't always this far away. And in the future, it won't be either. We build our lives around things we assume are constant. The moon. The seasons. The quiet ticking forward of time. But in reality, everything moves. Even the things that seem frozen. Especially the things that seem frozen. The moon's retreat is one of those facts that science confirms with confidence, but our senses completely ignore. No one lies awake at night feeling it leave. No one feels the pull getting weaker. It's a truth that exists beyond emotion, quiet, mathematical, and completely indifferent to our noticing it. This isn't the kind of motion that startles or alarms. It's not a meteor streaking through the sky or a solar flare lighting up the poles. It's background change. A kind of cosmic slow fade, like the dimming of a light bulb across centuries. And yet, the effects are real. The moon's departure affects Earth's rotation, the tides, even the length of our days. It's the kind of invisible event that quietly reshapes everything we think is stable. Long ago, when the moon was much closer, Earth's days were shorter, and the tides more dramatic. If you could stand on the ancient shorelines of early Earth, the moon would appear much larger in the sky. The water would rise higher and fall harder. The rhythm of life followed that pulsing beat. But time and motion work together, and the moon has been easing away ever since. With that distance comes change, subtle, long-term, and inevitable. There's something beautifully haunting about the idea that even the moon is leaving us. It's like realizing that your childhood home still exists, but the furniture's gone, the walls are painted a different color, and none of your things are there anymore. The place is still technically there, but it's not the same. The moon is still with us, yes, but it's not where it used to be. And it won't stay where it is now. This raises bigger questions, of course. Like what happens if the moon eventually moves too far? Could we survive without it? Would life even exist without its influence? Could it, in some unimaginable far future, drift away entirely, unbound from Earth forever? But those questions come later. For now, I want you to sit with the simpler, more grounded thought, that something you've always trusted to be constant, isn't. The moon, that nightly companion in the sky, is quietly disappearing from your life at the speed of a growing fingernail. You will never notice it with your eyes. But your descendants might. There's a softness to this idea. It doesn't demand fear. It doesn't even demand sadness. Just attention. Just wonder. You're living in one frame of a much longer time lapse. And in that frame, the moon is exactly where it should be, for now. So before you get comfortable, take a moment to like and subscribe to the video, but only if you really enjoy what I'm doing here. And if you're still with me, I'd love it if you left a comment with your location and local time. It's always beautiful to see where people are watching from, all under the same sky. Now dim the lights, maybe turn on a fan for that soft background hum, and let's start our journey together tonight. The moon is drifting away. Not metaphorically. Not spiritually. Literally. With each passing year, it inches a little farther from us, tugged outward by a subtle exchange of energy you never notice. You could live an entire lifetime, grow up, grow old, and the moon would have only moved about the width of a school ruler. But add that up over millions of years, and things begin to shift in ways that rewrite the rhythm of our world. This escape is powered by tides. Or more precisely, by the friction they cause. When the moon pulls on Earth's oceans, those tidal bulges don't line up perfectly beneath it. Earth spins faster than the moon orbits, so the bulges lag slightly ahead. That tiny offset creates a gravitational pull in return. Earth tugs back on the moon, ever so gently, like a rotating gear nudging another. Over time, that nudge robs Earth of rotational speed and transfers that angular momentum to the moon, pushing it outward in its orbit. This is not science fiction, it's physics. It's happening right now. And it's unstoppable. This process, known as tidal acceleration, is slow. Painfully slow. But also incredibly persistent. Like erosion or evolution, it changes the landscape not with force, but with time. And that time stretches across billions of years. Our current measurements show that the moon is receding from us at a rate of 3.8 centimeters per year. That might not sound like much, but multiply it by 100 million years, and you begin to see a drift that matters. If you could go back in time, say 1.4 billion years, the moon would have looked much larger in the sky, about 40,000 kilometers closer than it is today. The tides would have been more violent, sloshing the edges of continents and stirring coastal ecosystems in ways that probably played a role in the evolution of life itself. Even the length of a day was different. Back then, Earth completed a rotation in roughly 18 hours. The moon was closer, Earth spun faster, and the dance was tighter. As the moon moves away, Earth's rotation slows. That's the trade-off. The energy that pushes the moon outward comes at the cost of our own spin. It's why a day on Earth isn't 18 hours anymore, it's over 24, and still growing, 1 millisecond at a time. It's a subtle slowing, sure, but across geologic time, it adds up. And it forces us to think about time not just as clocks ticking, but as a planetary rhythm that is changing. Here's the part that feels hard to grasp: none of this is new. It's been happening since the moon was formed. And yet, only recently have we been able to measure it. Using retroreflectors, those mirrored panels placed by Apollo astronauts, we've bounced lasers off the moon and measured its distance with astonishing precision. Those quiet beams of light, traveling 384,000 kilometers and back, tell us what our ancestors couldn't: the moon is not fixed. It's leaving. That measurement changed everything. It gave us a new perspective on the moon, not just as a light in the sky or a mythic presence, but as a body in motion. And motion means change. It means consequence. It means future. One question people often ask is whether this drift will continue forever. Could the moon just keep pulling away until it slips free of Earth's gravity entirely? The short answer is no. Eventually, the system will reach equilibrium. Earth's rotation will slow to match the moon's orbital period, creating what's known as tidal locking, but this time, it goes both ways. Right now, the moon is already tidally locked to us, which is why we always see the same face. But in the far future, Earth will become tidally locked to the moon too. One side of Earth will always face the moon. Days and months will be the same length. It's a strange thought, but it's the natural conclusion of this long gravitational dialogue. That future is unimaginably distant, billions of years ahead. Long after the sun has grown hotter, long after oceans have boiled away. And yet, the process is happening now. Quietly. Relentlessly. Without pause. We live in a moving system, and that system is constantly exchanging energy, between Earth and Moon, between sea and land, between friction and flight. Let's step back for a second and imagine what the world would look like if the moon were suddenly gone, not shattered, not exploded, just gone. The tides would weaken dramatically. Some would still exist, caused by the sun, but they'd be smaller, slower. Coastal ecosystems would collapse. Many species that rely on tidal rhythms, crabs, turtles, shorebirds, would struggle or vanish. Weather patterns could shift. And Earth's axial tilt, which is currently stabilized by the moon, might begin to wobble wildly, leading to extreme, chaotic climate swings. That's how important this slow escape is. It's not just about movement in space. It's about stability on Earth. And yet, despite the importance, the moon's drift is not something we can change. We can't stop it. We can't reverse it. We can only measure it, imagine its consequences, and watch. That may feel unsettling, but there's a kind of peace in it, too. Some things move slowly enough that they give us time to reflect. Time to adapt. Time to wonder. The moon's escape isn't a threat, it's a reminder. A reminder that even the most stable things in our lives are temporary. They change. They leave. But they leave slowly enough that we can say goodbye. So as you sit there, maybe tucked under a blanket, maybe already drifting towards sleep, think about this. Even as everything else in your life feels fast and overwhelming, even as screens flicker and deadlines press in, the moon is gliding away at the pace of a fingernail. Quietly. Consistently. Without asking your permission. That's gravity for you. That's time. That's the rhythm you live in. And tomorrow night, when you see the moon again, it will already be a little farther away. Try to imagine a world without tides. Not just the subtle lapping of waves on a beach, but the entire planetary ballet of ocean bulges, shifting coastlines, and rhythmic rises and falls that have guided life for billions of years. Most of the time, when people think of the moon, they think of a distant light in the sky, a passive observer. But it's not just a glowing rock, it's an engine. It pulls Earth's oceans with invisible threads of gravity, sculpting the edge of every continent, moving water across the face of the planet like a slow, breathing lung. Without that engine, Earth wouldn't breathe the same way. The tides aren't just about water moving in and out. They are catalysts for life. In coastal regions, tide pools form small, temporary ecosystems that trap nutrients and organisms. These ever-shifting habitats helped early life move from sea to land. Without regular tidal surges, those ecological stepping stones might never have existed. Many biologists believe that the moon's pull played a critical role in shaping the very path of evolution. Even today, life continues to time itself by the moon's influence. Crabs scuttle to shore on exact schedules tied to lunar cycles. Coral reefs spawn in perfect synchrony during specific phases of the moon. Birds migrate, turtles hatch, and entire food chains adjust around the moon's quiet pulse. Remove that pulse, and these systems would begin to fall apart. But there's more. Tides help regulate the temperature of our oceans. They circulate nutrients and oxygen. They help mix surface waters with deeper currents. This mixing is vital. It prevents stagnation, supports plankton growth, and sustains the marine ecosystems that underpin the global food web. Without the moon's gravitational tug, this mixing would slow dramatically. Over centuries, parts of the ocean could become oxygen-starved. Fish populations would decline. Weather systems could shift. Entire regions could dry or flood, simply because the moon's tug was no longer there to stir the pot. There's also Earth's axial tilt to consider. Right now, the moon stabilizes our planet's tilt at about 23.5 degrees. That may not sound like much, but it's crucial. This tilt gives us seasons. Winter and summer, long days and short, these are all products of Earth being tilted just enough, and being held steady by the moon. Without it, that tilt would wobble wildly over long periods. Mars, for example, has no large moon to stabilize it. Its tilt has swung from almost straight up to over 60 degrees, causing extreme climate changes and long, planet-wide ice ages. If Earth lost the moon, we could expect the same. In fact, some scientists believe the moon is the reason Earth remains stable long enough for complex life to evolve in the first place. A moonless Earth might have been too chaotic for us to ever arrive. All of this from one drifting rock. And yet, even as it moves away from us, one fingernail's width a year, it continues to shape every shoreline, every storm system, every season. It's not gone. Not yet. But its influence is slowly diminishing. Here's where it gets interesting. The moon's departure isn't just a threat. It's also a record. The rate at which it moves away tells us about Earth's internal structure. About how energy moves through our planet. About how the oceans formed and evolved. Geologists study fossilized tidal patterns in ancient rock layers to figure out how far the moon was millions of years ago. That's right, there are literal stone records of how the ocean rose and fell eons ago, allowing us to estimate the moon's position through time. Every ripple in sandstone, every layer of sediment, is like a timestamp from the moon's slow journey. Even stranger, some of Earth's oldest fossils come from tidal environments. Stromatolites, layered microbial structures, thrived in shallow tidal zones over 3 billion years ago. These ancient colonies were shaped by daily flooding and draining, by sunlight and shadow, all coordinated by the moon's pull. Without those patterns, early life might never have developed photosynthesis, or formed the complex layers needed for multicellularity. So when you think of the moon as a light in the sky, think bigger. It's a builder. A regulator. A stabilizer. It's been holding the blueprint of life steady for billions of years. And as it drifts, that blueprint might subtly begin to change. Of course, all of this happens on timescales that are far too slow for you or me to feel. But still, it's happening. Right now, the tides are pulling energy out of Earth's rotation. The oceans are rising and falling in response. Coastal habitats are adapting. And the moon is inching away with every cycle. So the next time you're near the sea and you feel the water lapping at your feet, or you notice the shore pulling back just a little more than it did the day before, remember that you're not just watching the ocean breathe. You're watching the moon speak. You're standing in a conversation between Earth and its oldest companion, one that has been ongoing since long before humans, before dinosaurs, even before plants took root on dry land. And this conversation is not over. Not yet. But one day, far in the future, it will be. The moon will be too distant to create tides like the ones we know now. The oceans will still move, but they'll be quieter. The Earth will still spin, but more slowly. Life will still exist, probably, but different. That's the future the moon is steering us toward. Not through violence. Not through speed. But through soft, unrelenting movement. And tonight, while you rest, it's happening again. There's something inherently unsettling about the idea that something so large, so permanent seeming as the moon, could just leave us. We look at it night after night, suspended in the sky like it has always been there and always will be. But in truth, the moon's presence is a result of a violent past, a past written in fire and collision. And understanding how it came to be can help us understand why, and how it might eventually go. Roughly 4.5 billion years ago, in the turbulent infancy of the solar system, Earth wasn't alone. It shared its orbital neighborhood with another planetary body, one roughly the size of Mars. Scientists call it Theia. It's not just a poetic name, it's the name of a Titaness in Greek mythology, the mother of the moon. Fitting. Theia and Earth were on a catastrophic collision course. When they finally struck, it wasn't a minor bump. It was a glancing blow at interplanetary speeds, so violent that it vaporized much of Earth's outer layer and shattered Theia into debris. That debris, flung into orbit around the freshly reformed Earth, began to coalesce. Not into thousands of small moons like Mars has, but into one large, dominant sphere. The moon. This theory, the giant impact hypothesis, is our best explanation for how the moon formed. The isotopic fingerprints of moon rocks match Earth's outer layers almost perfectly. That means the moon is, quite literally, a part of Earth that was torn away and reshaped. It's not just our satellite, it's our sibling. Or maybe our scar. And yet, almost immediately, the moon began to retreat. Even in its birth, there was separation. Back then, it orbited much closer, so close, in fact, that it would have filled half the sky. Nights would not have been dark and silent, but lit by a looming, glowing sphere. Tides would have been monstrous. Days would have flown by in just a few hours. The Earth-Moon system was spinning so fast it was practically humming. But the same tidal forces that pull at our oceans today were already at work. The Moon began to slow Earth's spin and gain distance. The planet settled. The Moon's orbit widened. And slowly, stability emerged. This dance, this mutual shaping, has gone on ever since. And like all long-term relationships, it's changed both partners. Now think about this, the Moon is uniquely large compared to Earth. Most other moons in the solar system are tiny compared to their planets. Jupiter and Saturn have dozens of moons, but none as proportionally massive as ours. In fact, the Earth-Moon system is sometimes described as a double planet because of their relative sizes and gravitational interplay. That balance is delicate. If the Moon were much lighter or farther away, Earth's tilt would wobble chaotically, and life as we know it might never have emerged. So, what if something changed that balance? Let's say a rogue planet passed nearby. Or a massive asteroid impact altered the Moon's velocity. Or solar forces destabilized its orbit over eons. Could the Moon be knocked free? In theory, yes. If a large enough object passed through the solar system and tugged on the Moon's orbit, just slightly, it could start a slow, spiraling drift outward. It wouldn't be immediate. It wouldn't be catastrophic right away. But over millions of years, that small tug could unmoor the Moon from Earth's gravitational hold. And the consequences wouldn't just be astronomical, they'd be ecological, geological, even psychological. Culturally, we're tied to the Moon in ways we don't always recognize. Calendars, myths, folklore, religious observances, even our language. Moonlight, lunacy, once in a blue moon, these are not just metaphors, they're echoes of how central that pale circle is to the human imagination. Take that away, and something deep in us changes. But science doesn't rest on metaphors. And right now, physics tells us that the Moon is drifting, not fleeing. It's not about to disappear from the sky next week, or even next epoch. We're talking billions of years. Yet there's a strange comfort in knowing it's not permanent. That the Moon is not a fixed icon but a dynamic partner. That it's still writing its own story. And as we observe its phases, measure its distance, and study its shadows, we're learning more not just about the Moon, but about ourselves. About how our planet works. About how life adapts to long, slow cycles. About what it means to be a species living under the influence of something so familiar, yet so alien. Because let's face it, the Moon is not hospitable. It's covered in dust finer than flour, sharp as glass. It has no atmosphere, no weather, no sound. The temperature swings are brutal. And yet, we are drawn to it. We've walked on it. We dream of going back. Some even talk of colonizing it. Maybe that's our way of holding on, of resisting the idea that it's drifting away. But you can't stop gravity. And while the Moon's escape is slow, it is inevitable. So tonight, as you lie there and maybe glance out the window, if you're lucky enough to catch the Moon glowing above, just remember, it used to be closer. And one day, it will be gone. Not with a bang. Not with drama. Just with distance. And in the silence between now and then, there's time to wonder. If the Moon were to vanish, not gradually, over billions of years, but suddenly, in a blink, it would be more than just a cosmic oddity. It would be a planetary emergency. The effects would begin immediately, rippling through the natural world in ways most of us wouldn't expect. And while it might not tear Earth apart, it would unbalance everything we consider normal. First, the tides. Roughly 60% of Earth's tidal movement is driven by the Moon. The Sun contributes the rest, but the Moon is the real architect of the twice-daily rise and fall we see along coastlines. Remove the Moon, and those tidal forces collapse. The tides wouldn't vanish completely, but they would shrink dramatically, perhaps by 2/3. That means less mixing of ocean layers, less circulation of nutrients, and a huge disruption to ecosystems dependent on those patterns. Many species time their lives to the tides. Horseshoe crabs come ashore to breed during specific lunar phases. Sea turtles lay eggs according to the pull of the moon. Salmon migration, coral spawning, bird nesting cycles, all rely on subtle rhythms tuned to gravitational cues. Disrupt the beat, and the whole orchestra falls out of sync. Ecosystems don't collapse overnight, but over a few generations, the loss would echo loudly. Entire chains of life might vanish simply because the clock they followed stopped ticking. But the loss of the moon would also reach inland. Earth's axial tilt, currently stable at about 23.5 degrees, is kept steady in large part by the moon's gravitational tug. Without it, our axis would begin to wobble over time. These wobbles, or chaotic obliquity, would lead to massive and unpredictable climate shifts. In the short term, seasons might grow more extreme. Summers hotter. Winters harsher. Over longer timescales, Earth might tilt so far it rotates sideways, like Uranus. Imagine polar regions receiving more sunlight than the equator. Imagine glaciers at the equator and tropical forests at the poles. Life could adapt, but slowly. Human civilization, on the other hand, isn't great with slow adaptations. A slight shift in rainfall patterns can spark wars. A decade-long drought can collapse empires. Now imagine climate change not as a human-driven event, but a natural response to a missing moon. It's a chilling thought, no pun intended. Then there's the psychological aspect. For as long as humans have existed, we've lived under the moon's light. We've told stories about it, worshipped it, tracked time by it. Farmers plan crops around lunar cycles. Sailors navigated by moonlight. Poets and scientists alike stared upward and found inspiration. Take that light away, and something primal is lost. The night sky would be wrong. Empty. The stars would shine more brightly, sure, but they wouldn't fill the gap. People would notice immediately. They'd look up and instinctively feel something is missing, like an empty frame on the wall where a familiar portrait used to hang. Even without knowing the science, there would be grief. And if you're wondering whether this could actually happen, if the moon could be destroyed or pulled away, the answer is, not easily. Its orbit is incredibly stable. It would take an enormous gravitational event to alter it significantly, something like a rogue planet wandering through the solar system. Or, more dramatically, a massive collision with a space object hundreds of kilometers wide. If that happened, the debris would pose an even greater problem. Instead of a single, predictable moon, Earth could be surrounded by a ring of orbiting rubble, like a smaller version of Saturn's rings, but unstable, constantly raining down rock. The night sky might glow with streaks of falling debris. Satellites would be shredded. The International Space Station, GPS networks, weather systems, all gone. In the worst-case scenario, fragments of the moon could fall to Earth. Even small pieces would hit with tremendous energy. We're talking continent-scorching impacts. But even if the fragments missed us, their gravitational influence wouldn't. Earth might briefly have multiple smaller moons, each pulling on the oceans and atmosphere in conflicting ways. Weather patterns would break. Earthquakes might increase as the planet's crust adjusted to a new gravitational reality. And yet, in the grand scale of the universe, this isn't unheard of. Moons can be stripped from planets. Gas giants in distant solar systems have likely lost their satellites to stellar tides or collisions. Even here in our solar system, Uranus rotates on its side, likely the result of a moon-forming impact gone wrong. So while our moon is stable for now, cosmic history reminds us that stability is never permanent. But maybe that's part of the point. We tend to think of the moon as a quiet, decorative object. Something static. But its existence is the result of chaos, of impact, of reshaping, of resilience. It formed from fire. It sculpted life. And even as it drifts away, it continues to hold our world together. Take it away suddenly, and you remove more than just gravity and light. You remove history. You remove balance. You remove a partner in the grand cosmic dance. So tonight, if you glance up and see it glowing, maybe just a sliver, or maybe full and bright, know this, it's not guaranteed. It's a gift. A fragile, drifting companion. And it's still with us. For now. You might be wondering, if the moon really does so much for Earth, why is it moving away in the first place? It seems counterintuitive. Shouldn't gravity be holding it firmly in place? Shouldn't the bond between Earth and its moon remain unbreakable? But in reality, the laws of physics say otherwise. The moon is moving away. Not because something is pushing it, but because of how energy flows between the Earth and the moon, primarily through a process called tidal acceleration. Here's how it works. As the moon's gravity pulls on Earth's oceans, it causes the tides to bulge. But because Earth is spinning faster than the moon orbits, the bulges are always slightly ahead of the moon's position. This means Earth is essentially dragging the tidal bulge forward. That forward drag pulls on the moon, giving it a tiny push. Over time, that push causes the moon to speed up in its orbit. And just like a figure skater who speeds up by extending their arms, the moon responds by moving farther out. The numbers are precise. The moon is receding from Earth at about 3.8 centimeters per year. That's roughly the speed your fingernails grow. It's barely noticeable in a human lifetime, but over millions and billions of years, the effects become profound. Long ago, days on Earth were just a few hours long. In the far future, they'll stretch to 30 or even 50 hours. Eventually, Earth and the moon could become tidally locked to each other, just like the moon is already tidally locked to Earth. That means one side of Earth would always face the moon. From that side, the moon would hang motionless in the sky, never setting, never rising. On the other side of the planet, it would never be seen at all. This scenario might seem strange, but it's completely plausible, and it's just one step before the moon escapes entirely. But will it ever truly leave? Maybe not. The sun complicates things. As the moon drifts outward, Earth's spin slows, and the whole system becomes more delicate. But long before the moon escapes Earth's gravity, something else happens. The sun begins to die. In about 5 billion years, our sun will swell into a red giant. Its outer layers will expand, potentially engulfing Mercury, Venus, and even Earth. As the sun's mass changes, its gravity weakens, and the orbits of the planets and their moons become unstable. At this point, the fate of the moon becomes uncertain. It might spiral away faster due to the loss of gravitational balance. Or it might be pulled into a new orbit, depending on how the Earth is affected. If Earth itself is destroyed or scorched to a barren cinder, the moon could become an orphan, circling a dead world. Or perhaps it will drift off on its own, a cold relic of a lost home. Now consider this, even if the moon doesn't leave us violently, its absence will be felt long before it's physically gone. As it recedes, its ability to influence tides and Earth's axial tilt diminishes. Gradually, the seasons might begin to shift. The tides would weaken. The rhythms of life would become less pronounced. Civilizations might notice. They might measure the weakening tides and recalibrate calendars. New myths might arise about why the moon appears smaller in the sky. Poets might lament its fading presence. Scientists might issue warnings. Generations would pass with each new era having a slightly different moon. Smaller. Dimmer. Quieter. It's a poetic kind of disappearance, so slow and subtle that no one alive would ever see it happen. But the truth would be etched in long-term observations, in astronomical records, and in the stories passed down through time. Now imagine you're living thousands of years in the future. You open a history archive and find that ancient people once saw a massive moon hanging in the sky, casting tides, inspiring myths, guiding sailors. And now, it's a speck. Or maybe, it's not even there anymore. Would you feel a sense of loss for something you never truly knew? There's something deeply human about mourning in advance. Knowing something precious is slipping away and feeling the weight of that future absence. The moon, in many ways, is part of our collective identity. Its slow departure is like watching an old friend take a long walk into the distance, not running, not vanishing, just getting smaller until they finally fade from view. But maybe that's what gives it meaning. The moon isn't just a rock in space. It's a reminder of Earth's past, a partner in its present, and a clue to its far-off future. And in that way, even if it does leave us, it will never truly be gone. Its fingerprints are on every coastline, every fossilized ripple, every myth ever told under its light. So tonight, while the moon is still here, still close enough to touch with your eyes, look up. Let your mind stretch across the distance. Imagine its slow journey. Not a flight, but a drift. A graceful, inevitable goodbye. And in that quiet, in that cosmic patience, maybe you'll find comfort. Because even in leaving, the moon teaches us how to stay. Let's shift the lens a bit. Instead of focusing on the moon's future departure, let's talk about what it means to have had the moon in the first place, and just how different Earth might have been without it. Because when you start removing celestial bodies from the equation, you don't just change the night sky. You rewrite the entire history of life. Without the moon, Earth wouldn't just look different. It would be different. Let's start with Earth's tilt, the angle at which our planet leans as it orbits the sun. Today, that tilt is about 23.5 degrees, and it's relatively stable. This is what gives us our seasons. It's why the poles experience long, frigid winters and the equator stays warm year-round. It's why agriculture follows predictable cycles. The moon plays a critical role in stabilizing this tilt. Without it, Earth's axis would be much more vulnerable to the gravitational influences of Jupiter, the Sun, and even other planets. Over thousands or millions of years, Earth could wobble dramatically, swinging between no tilt at all and extreme angles of 60 degrees or more. With no tilt, no seasons. Every place on Earth would experience roughly the same weather year-round. Agriculture would collapse in most regions. Wildlife would lose the environmental cues it relies on to migrate, hibernate, and reproduce. With a high tilt? Well, imagine the North Pole pointed directly at the sun for months. Half the planet scorched. The other half locked in eternal darkness. Ocean currents would stop behaving the way they do. Jet streams would become chaotic. Deserts could form in the Arctic, while jungles might bloom at the South Pole. This isn't just speculation, it's backed by models. Without the moon, Earth could have become an unstable, chaotic world. Still habitable, perhaps, but inhospitable to complex life as we know it. Especially to the kind that wears headphones in bed and listens to videos about space. And then there's the question of time. Not metaphorical time. Literal, measurable, calendrical time. We base our months on the moon's cycle. The word month literally comes from moon. In cultures around the world, from the Islamic lunar calendar to traditional Chinese festivals, timekeeping has been linked to the moon for millennia. Farmers relied on lunar phases to plant and harvest crops. Ancient mariners used the moon to predict tides and navigate. Even today, we instinctively link certain times of the month to its waxing and waning presence. Take the moon away, and you remove one of the earliest tools humanity had for understanding time. We'd be left with the sun alone, still a decent clock, but not nearly as precise or visible at night. Early civilizations might have struggled to organize their calendars. Religious observances would shift. Societies would evolve with different rhythms. Culture itself would be shaped differently. You could argue that, without the moon, human civilization might have developed more slowly, or along entirely different lines. Perhaps we'd be more solar-focused. Maybe astrology would never have formed. Maybe poetry would have looked to stars instead of moonlight. Or maybe we'd be too busy surviving harsh, erratic climates to build temples or write anything at all. Now consider this. We wouldn't have tides in the same way, so early humans might never have settled near coastlines. No reliable fishing grounds. No tidal pools to experiment with. No predictable harvests from the sea. That might sound like a small detail, but these edge zones, where land and ocean meet, are crucial for biodiversity and early food sources. Even human biology shows hints of lunar influence. Some researchers have found correlations between the lunar cycle and sleep, mood, and even reproductive rhythms. The data isn't perfect, but it's suggestive. In many cultures, menstruation has been metaphorically linked to the moon, with cycles of roughly the same length. Coincidence? Maybe. But maybe not. In short, no moon, and you don't just get a darker night. You get a different Earth. This brings up a weird philosophical question: is the moon part of us? Not just geologically, but historically? Psychologically? Spiritually? Because it didn't just show up one day like a borrowed ornament. It came from us, from a collision that reshaped Earth and left behind a companion. That companion has shaped our tides, our tilt, our calendars, our dreams. It's been a quiet co-author of every major chapter in our planet's story. And now it's leaving. Slowly, yes. But definitely. So, in a way, we're living in the golden age of the Earth-Moon relationship. Close enough to inspire awe. Far enough to be stable. Present enough to shape our nights. Distant enough to let us imagine what life will be like without it. And maybe that's the whole point of this thought experiment. To recognize that what we see is permanent, those constants in the sky, the rhythms of the Earth, are actually fleeting. Measured on a cosmic timescale, even the moon is temporary. And knowing that gives us a reason to appreciate it while it's here. Tonight, when you step outside and feel the cool air and see the moon hovering above the rooftops or trees, maybe take a moment. Not just to admire it, but to thank it. Because without it, you probably wouldn't be here at all. Let's go back, way back. To the very beginning of this relationship. Because if we're talking about the moon and the question of whether it could ever leave us, we can't ignore how it got here in the first place. Spoiler, it didn't just show up. It wasn't captured. It wasn't built. It was born in fire. Roughly 4.5 billion years ago, not long after Earth itself had formed, the early solar system was a brutal place. Planets were still growing, collisions were common, and stability was rare. Earth, at that time, was a molten, barely cooled sphere surrounded by debris. And one of those wayward bodies, about the size of Mars, slammed into it. That object has a name now, Theia. The collision wasn't just a bump. It was a full-body slam, an impact so violent it liquefied much of Earth's surface. Debris exploded outward, forming a halo of rock and vapor. Most of it fell back to Earth, but some escaped just far enough and fast enough to stay in orbit. Within weeks or months, maybe a few years at most, this material coalesced. Gravity sculpted it into a sphere. And just like that, the moon was born. That's the giant impact hypothesis, and it's the leading theory because it explains so many things: the moon's similar composition to Earth's outer layers, the tilted angle of Earth's axis, and the relatively low presence of volatile elements in both bodies. It's like a cosmic fingerprint, we're made of the same stuff. But here's the strange part, that impact probably made life possible. For one, it gave Earth a massive satellite almost right away. Most planets don't have moons like ours. Venus and Mercury have none. Mars has 2 tiny ones, more like space potatoes than moons. But Earth? We won the lottery. The moon we ended up with was huge, proportionally speaking. And that size matters. It meant stronger tides. A more stable axial tilt. A faster cooling process for Earth's molten surface. Some researchers even think that early tidal pools, warmed by the sun and stirred by lunar gravity, may have been cradles for early life. Without that gentle push and pull, those vital chemical reactions might have taken longer, or might not have happened at all. So not only did the moon help create the conditions for life, it might have also been born because Earth nearly didn't survive. Let's sit with that for a second. Our moon is a scar. A reminder of a near-death experience. Earth was almost obliterated in that collision, and yet out of that destruction came something beautiful, stable, and essential. It's not just poetic, it's physical. Every night you look up and see the moon, you're seeing the result of one of the most violent moments in Earth's history. And it's stuck around. Not as an intruder, not as a passenger, but as a partner. Locked in this gravitational embrace, slowly spiraling outward. You could even say that Earth and the moon have been dancing ever since, but with a strange twist, only one of them is leading, and the other is trying to leave the floor. Over time, that departure has become more pronounced. We've measured it. We know it's happening. But we also know this relationship isn't done yet. There's still time. Billions of years, perhaps, before any true break happens. That gives us space to reflect, to appreciate, and yes, to speculate wildly. Because let's be honest, once you start thinking about how the moon got here, you naturally start asking whether things had to be this way. What if Theia had missed? What if Earth had ended up moonless? Or with multiple moons? What if the debris had scattered or failed to form a sphere? There are simulations that show Earth with rings instead of a moon, temporary bands of rock like Saturn, gradually falling to Earth over time. But we got a moon. Just one. Big, bright, and persistent. And here's a curious thought, maybe that's why we evolved to care about the sky. Not because it's there, but because something in it was large enough, regular enough, and important enough to demand our attention. The moon didn't just inspire songs and calendars. It focused our gaze. It taught us to watch, to wait, to measure change over time. That's no small thing. In a universe of chaos, a consistent presence like the moon gives meaning to movement. It turns night into a canvas. It offers scale to an otherwise overwhelming sky. It gives us a way to see our place in a much larger system. Now here's where it gets wild. We've been to the moon. That distant companion we stared at for millennia? We landed on it. We walked on it. We brought pieces of it back to Earth. Humans, not gods, not myths, but ordinary humans, built machines, traveled 250,000 miles, and stepped onto a world born from our own shattered beginnings. And what did we find there? Dust. Silence. A kind of lifeless stillness. But also, a mirror. Not a literal reflection, but a reminder of who we are and where we came from. The moon isn't just a rock, it's our twin. Our witness. Our relic. If one day it does leave, if time, physics, or fate eventually sends it drifting into the dark, it won't go quietly. Not in memory. Not in meaning. Even if it's no longer visible in the sky, it will echo in everything it helped shape, the tides, the tilt, the trees, the humans. You. Because the moon, in a very real way, helped make you possible. If you've ever stared at the moon and felt like it was watching you back, you're not alone. There's something about its constant presence, the way it always shows the same face, that makes it feel alive. Not sentient, of course, but familiar, like it's been keeping an eye on us all this time. And maybe, in its own way, it has. But this chapter is about what comes after us. Let's say humanity disappears. Maybe in 1,000 years, maybe in 100,000. Doesn't matter how or why, we're gone. Earth is still here, battered but spinning, and the moon continues to orbit. Alone. Quiet. Witness to a planet that once teemed with life. And yet, long after we're gone, the moon remains one of the only things that will bear evidence we were ever here. Let's take a walk across the lunar surface. It's not like Earth. There's no wind, no rain, no plate tectonics. Nothing erases footprints. Nothing rusts. Nothing grows. It's a static archive, a dusty museum with no staff. That means the Apollo footprints? Still there. The discarded landing modules? Still sitting where they were left. Even the experimental equipment we abandoned, like retroreflectors that still bounce lasers back to Earth, are there, silently waiting. No natural process is erasing our presence. The moon is, quite literally, a time capsule. In fact, some scientists suggest that future civilizations, human or otherwise, will one day discover these relics and recognize them for what they are, signs of intelligence. Machines. Tools. Geometry that doesn't occur in nature. Evidence of a species that reached out to its satellite not out of necessity, but out of curiosity. It's a comforting thought, in a strange way. That even after Earth erases us, through erosion, tectonics, overgrowth, or collapse, there will be a record of our existence etched in dust 384,000 kilometers away. But what if we go farther? Let's say we colonize the moon. Build bases, habitats, mines, communications hubs. It's not science fiction anymore. Serious plans are being drawn by NASA, ESA, and private companies to return to the moon, and not just for a visit. This time, we're talking long-term presence. But how would that affect our relationship with the moon? In one sense, it would bring us closer. Not just symbolically, but materially. We'd be tied to the moon with trade, travel, infrastructure. We'd have citizens living under its regolith. Children born with lower gravity in their bones. A second home. But here's the twist: the more we exploit the moon, the more we alter it. Strip mine enough of its surface, and we could change its mass distribution. That affects its orbit. Build large-scale structures or deploy satellites in low lunar orbit, and we create hazards, debris fields, shadows. Could we accelerate the moon's departure? Maybe. Not by much, not quickly, but the principle is there. Interfere enough with a stable system, and you start to introduce chaos. It's the same dilemma we face with climate change: death by 1,000 small decisions. But here's a more philosophical question: once we live on the moon, does it stop being a symbol and become just another place? Because right now, it's a canvas for our stories. A distant, unreachable object of beauty and mystery. We see it in poetry, romance, horror, mythology. Werewolves howl at it. Lovers walk under it. Children dream of flying to it. Entire religions have revolved around its cycles. Once we industrialize it, dig it up, pave it, populate it, does it lose that mystique? Or maybe it gains something new. Maybe our presence on the moon doesn't diminish it, it expands it. Just like we look at Earthrise photos from Apollo missions and feel something deep and unshakable about our home planet, maybe seeing a colony on the moon will help future generations grasp the scale of human possibility. That we can reach beyond what we were given. That we can build, not just survive. Still, the moon's emotional weight won't go away easily. There's a reason no other planet's moon gets this much attention. Saturn's Titan has lakes of methane. Jupiter's Europa might have alien life beneath its ice. But it's our moon, the one you can see without a telescope, that feels like it belongs to us. And perhaps that's why the idea of it leaving is so unsettling. It's not just orbital mechanics or gravitational dynamics. It's a fear of losing something we didn't just observe, but share our history with. Imagine looking up one night and not seeing it. Just stars. Cold, distant, unblinking. A clean sky. Too clean. What stories would we stop telling? What dreams would fade? What rhythms would falter? Because even if we replace the moon with artificial satellites, with calendars and clocks and weather apps, something primal would be lost. We evolved alongside that glowing rock. Its cycles taught us time. Its light gave us navigation. Its silence gave us space to wander. And in its slow, inevitable departure, we are being reminded that everything, even the things that feel eternal, can drift away. But maybe that's not tragic. Maybe that's the nature of all relationships, cosmic or otherwise. To arrive by accident, to shape each other, and to slowly part ways. Not with anger. Not with loss. But with gratitude. So the next time you see the moon, whether it's full and bright or just a sliver in the sky, take a second to notice it. Really notice it. Because one day, far beyond your lifetime, it might not be there at all. And on that day, someone, or something, might look up at the empty sky and wonder what it was like when Earth had a companion. Let's talk about scale for a second. Because when we say the moon is drifting away, it might sound like a slow crawl, or maybe it sounds dramatic, like it's packing its bags and heading off to another galaxy. In reality, it's both underwhelming and profound. It's moving away at about 3.8 centimeters per year. That's roughly the speed your fingernails grow. But zoom out. Take that speed and multiply it by millions, billions, of years, and the distance becomes noticeable. Already, the moon is about 18 times farther away than it was when it first formed. At that time, it would have loomed huge in the sky. Imagine looking up and seeing a moon 5 times bigger than it is now. Not just brighter, dominant. A sky-filling presence. Ancient humans never saw that. Not even the dinosaurs did. That version of the moon belonged to the very beginning. And what's the mechanism behind this slow exit? It all comes down to tidal friction. As the moon's gravity pulls on Earth's oceans, it creates tides. But Earth spins faster than the moon orbits, so the tidal bulges are slightly ahead of the moon. That offset creates a kind of gravitational tug, pushing the moon forward in its orbit and causing it to gain energy and gain distance. Meanwhile, Earth pays the price. That same process is slowing down our rotation. Every year, our days get a tiny bit longer. In the time of the dinosaurs, a day was about 23 hours. In a few 100 million years, it'll be over 25. It's a cosmic trade. We give the moon energy, and it drifts away. We lose speed, and our days stretch. It's a beautiful, slow-motion balancing act. But it's not forever. At some point, likely billions of years from now, this process will reach equilibrium. Earth's rotation will match the moon's orbit, and both bodies will be tidally locked. That means one side of the Earth will always face the moon, just like the moon already always shows us one face. Can you imagine that? If you live on the moon-facing side of Earth, the moon will always be in your sky. Always full. Always present. Just hanging there like a ghost lantern. If you live on the opposite side, you'll never see it again. A sky permanently moonless. That's not science fiction. That's the likely future, assuming nothing else interferes. But things do interfere. The sun, for one. As it ages, it will grow into a red giant, swelling in size and eventually engulfing the inner planets. Long before that happens, it will boil away Earth's oceans and strip our atmosphere. The moon, at that point, won't matter much. It might still orbit a scorched, airless Earth, or it might be ripped away by tidal forces as the sun's gravity warps the solar system. And if we don't make it that far? Well, there's another possibility. That something massive, another celestial body, an asteroid, or rogue planet, disrupts the Earth-Moon system. It's unlikely, but not impossible. Space is a violent place. A close gravitational encounter could sling the moon away, permanently. Or we could do it ourselves. Think of the technology we're developing: space tethers, mass drivers, orbital manipulation. If we ever became advanced enough, and let's be clear, this would require a level of energy and precision far beyond anything we have now, we could intentionally alter the moon's orbit. Maybe to prevent a future collision. Maybe to harvest its mass. Maybe just because we could. It would be the ultimate act of arrogance. To undo billions of years of cosmic choreography. To erase the moon from our sky by choice. And what would that cost us? Besides the scientific effects, chaotic tides, an unstable axis, disrupted ecosystems, we'd lose something psychological. A symbol that's followed us through every age. Every cave painting, every telescope, every lullaby. Gone. It's strange how loss works at this scale. If you lose your phone, it's frustrating. If you lose a person, it's heartbreaking. But to lose the moon? That's a kind of existential disorientation. You'd look up, and something fundamental would be missing, not because you saw it consciously every night, but because your species evolved with it. Now flip it around. What if the moon wasn't natural? What if it was never ours to begin with? Some fringe theories, none supported by science, but compelling as thought experiments, suggest the moon is artificial. A hollow satellite. A constructed object placed in orbit for observation or manipulation. Again, there's no evidence for this. But it reflects something deeper, our intuition that the moon is too perfect. Too large for its host planet. Too neatly locked in its orbit. The odds of a body that size being just the right distance to produce perfect solar eclipses, where the moon covers the sun almost exactly, are astronomically low. Coincidence? Sure. But humans don't like coincidences. We like meaning, stories, intent. And even if the moon is a perfect accident, isn't that more amazing? That out of the chaos of the early solar system, a giant impact just happened to create the conditions for life, balance Earth's tilt, stabilize the climate, give rise to tides, and later host our first steps into space? It's almost too much meaning. And that's the beauty of it. The moon, whether you view it through a telescope or a myth or a mathematical model, remains slippery. It's real, but mysterious. Close, but distant. Familiar, but unknowable. And soon, or eventually, or someday, it'll be gone. So what do we do with that knowledge? We can't stop it. We can't hold it in place. But we can remember. We can honor it. We can look up more often, point it out to our kids, watch the shadows change as it waxes and wanes. We can build art, write songs, record dreams. We can say thank you, quietly, to the light in the sky that never needed to care, but still shaped everything we are. The moon doesn't belong to us. But for now, it's with us. And that's enough. Let's imagine a scenario. Not science fiction, just a tweak of real physics. Suppose, somehow, the moon vanished overnight. No explosion, no debris, just gone. You wake up, step outside, and there's nothing in the night sky but stars. What happens next? At first, probably nothing dramatic. You might not notice it right away, especially if it's a new moon or it's cloudy. But then the tides change. Or rather, collapse. Because about 70% of Earth's tidal energy comes from the moon. Without it, the oceans would still rise and fall, but the rhythm would be weaker, more erratic. Solar tides would remain, but the balance would be off. For coastal ecosystems that depend on tidal timing, crabs, turtles, intertidal plants, the effect would be enormous. Spawning cycles, feeding grounds, all thrown into chaos. Some species might adapt. Others might not. But tides aren't just about marine life. They affect ocean currents, and ocean currents regulate climate. Remove the moon, and Earth's thermal regulation gets a little sloppier. Over time, this could lead to regional climate shifts. Nothing apocalyptic, but enough to tip ecosystems, cause droughts, maybe even trigger feedback loops in already vulnerable areas. Then there's Earth's axial tilt, currently around 23.5 degrees. That tilt is what gives us seasons. But it's not locked in place. Earth wobbles, like a top, and over thousands of years, that wobble changes slightly. The moon helps stabilize it. Take the moon away, and the wobble becomes less predictable. Some models suggest Earth's tilt could vary wildly, from almost no tilt to as much as 85 degrees. That's not just hotter summers or colder winters, that's the Arctic pointing at the sun. That's equators freezing and poles burning. Not tomorrow. Not even in 1,000 years. But eventually. So in the absence of the moon, Earth becomes a more chaotic, less predictable place. Still habitable, but with greater extremes. More risk. Less rhythm. But here's the more immediate loss, the psychological one. People all over the world would look up and feel something missing. Not like a blackout. More like a heartbeat that's stopped. A reliable presence, suddenly gone. No full moon hikes. No crescent slivers at dawn. No eclipses. Just a naked sky. Astronomers would scramble. Every news outlet would lose its mind. Theories would fly. Was it a wormhole? An alien theft? A glitch in the simulation? But eventually, the shock would wear off, and we'd be left with the quiet. That's the thing about losing something constant, you don't realize how many parts of your world are tied to it until it's gone. There'd be practical shifts, too. Farmers and sailors still use lunar cycles in some regions. Religious calendars, like the Islamic and Hebrew calendars, are lunar-based. Cultural events, festivals, ceremonies tied to the moon's phases would drift into confusion. And then there's art. No more moonlight sonatas. No more moon in poetry, in lullabies, in symbolism. future generations might read about it the way we read about Atlantis or dragons, part history, part myth. A celestial ghost. So if the moon could leave us, whether by physics or by fiction, we'd lose more than gravitational balance. We'd lose a thread woven into the fabric of being human. And maybe that's what makes the idea so haunting. Because here's the deeper truth, the moon was never really ours. We didn't choose it. We didn't earn it. It was just there, looming, glowing, pulling at our waters and our stories. We grew up in its light, evolved to its rhythm, synchronized ourselves to its dance. And one day, it could just not be. But perhaps that inevitability gives us an opportunity to look while we still can. To notice. To point it out on a walk, take a photo, trace its edge with your finger. Not as a cosmic placeholder, but as something fleeting. Because maybe everything we love is a little more beautiful when we know it won't last. And here's one final thought, if we ever lose the moon, not through collision, or physics, or negligence, but through time itself, maybe that moment becomes a marker. The end of one era. The beginning of something else. Not a tragedy. Not a disaster. But a whisper of everything that once was, and everything we had the privilege to witness. When we talk about the moon leaving us, it's tempting to frame it as a loss. And yes, in many ways, it would be. But part of understanding this scenario fully means stepping back, way back, and asking a deeper question. How did we even get the moon in the first place? You might assume it was always there. That Earth formed with the moon spinning beside it, like two dancers who join the waltz at the same time. But no, the moon has a dramatic origin story. It starts about 4.5 billion years ago, during the chaotic early days of the solar system. Earth was still forming, a hot, young planet surrounded by debris. And then came the collision. A Mars-sized object, nicknamed Theia, slammed into Earth at a shallow angle. The impact was unimaginably violent. Debris from both Theia and Earth was launched into orbit. Some of it rained back down. But a large portion coalesced, gravity tugging it together into a new body. That was the beginning of the moon. That's the leading theory anyway, called the giant impact hypothesis. It's supported by computer models, the composition of lunar rocks, and the physics of orbital mechanics. It also explains why the moon's density is lower than Earth's. It formed from Earth's crust and Theia's remains, not Earth's heavy core. So from the very beginning, the moon was a consequence. A byproduct of chaos. It didn't form alongside Earth, it was born of Earth, in a moment of violence. And maybe that's why our relationship with it is so complex. It's not just a neighbor. It's family. And like all family, it's changed over time. In its early days, the moon was much closer, about 16 times closer than it is today. That means it loomed gigantic in the sky. Nights would have been bright, tides would have been enormous, and its gravitational pull on Earth's interior might have been strong enough to trigger more volcanism and earthquakes. But as it moved away, Earth began to settle. The tide shrank. The days grew longer. Life started to flourish, perhaps because of the moon's influence. Some scientists even suggest that tidal pools created by the moon's gravity may have been the perfect nursery for the chemistry of early life. That's not certain, of course. But it's compelling. The moon wasn't just a passive light in the sky, it was an active participant in Earth's story. So what happens if that participant exits? Well, in a very long-term sense, it means Earth goes back to being alone. Not companionless, there are still planets, stars, the sun, but without that one, ever-present partner. And that absence ripples outward. It's not just science that's affected. It's identity. Because the moon has always been more than its mass and orbit. It's been a mirror, a way for us to see ourselves from a distance. It shows us time through its phases. It shows us scale through eclipses. It's a constant when everything else feels temporary. Now imagine a future where humanity ventures out into the stars. We colonize Mars, maybe even planets beyond. We leave the solar system entirely. In that future, the moon becomes a relic. A place we visit for history, not necessity. A kind of celestial birthplace, like a childhood home we no longer live in, but still remember. And yet, even in that far-off future, the moon would be a unifying memory. No matter how far we travel, every human ancestor was shaped under its light. That connection won't fade. Unless, of course, the moon does. Then what? Well, then the memory becomes even more precious. The moon becomes a legend. A story we tell to children on other planets. A soft light that used to hang in Earth's sky, guiding tides and dreams, now lost to distance or disaster. We might simulate it. Artificial moons in orbit around future Earths. Holograms. Renderings in museums. But none of it will quite feel right. Because the real thing, the mass, the history, the pull, will be gone. And here's the most haunting possibility. What if future humans, or other intelligent species, don't remember the moon? What if it disappears slowly, and over generations, its presence fades from stories, from data, from memory? Maybe the remnants are buried beneath new civilizations. Maybe our lunar relics are mistaken for natural formations. Maybe it becomes a mystery, an oddity in ancient texts with no clear reference point. And in that moment, the moon's departure won't just be a physical loss. It will be a loss of context, a piece of the puzzle gone forever. That's why imagining the moon leaving us isn't just about physics. It's about what stays behind. And if you're listening to this now, under the moon's glow or with its cycle in your calendar or its memory in your mind, you are part of that legacy. You are part of the age when Earth had a moon. Now let's shift the lens a little. We've talked about the moon as a companion, a stabilizer, a source of tides and timekeeping, but have you ever thought about how much culture has been shaped by it? Let's say the moon does leave us. Besides the physical changes to Earth's rotation or climate, the cultural void it would create might be even more jarring. Because the moon is not just in our sky, it's in our stories. From the first humans painting crescent shapes on cave walls to modern films depicting lunar colonies, the moon has occupied a mythic space in our minds. Ancient Mesopotamians named it Sin, associating it with wisdom. In China, it became the home of Chang'e, the goddess who floated upward, leaving Earth behind. The Greeks gave it to Selene, the radiant figure who drove a chariot across the night sky. Nearly every culture on Earth assigned it a deity, a legend, or a role in fate. Even our calendars bow to it. The word month comes from month, because lunar cycles were once the most obvious and reliable way to measure time. Festivals, religious holidays, harvest cycles, these were tied to the moon's phases long before atomic clocks and digital scheduling. So if it disappeared, what happens to all of that? Imagine a future civilization where the moon is gone, but remnants of its importance still linger, rituals with unclear origins, superstitions about nighttime behavior, architectural alignments pointing at nothing. A lost reference point in a language we no longer fully understand. It's like removing the beat from a song. The melody may continue, but something essential is missing. Something that gave rhythm to it all. Even modern culture is full of lunar echoes. Think of the words, moonlit, moonstruck, lunacy. That last one, lunacy, comes from the Latin luna, because for centuries, people believed the moon could affect your mind. Emergency rooms report busier nights on full moons, even if the data is inconclusive. It's in our bones to think the moon stirs something in us. So what stirs in its absence? The answer might be silence. The kind of silence that settles when you realize a familiar sound is gone, a ticking clock, a creaking floorboard, a whisper of wind that used to accompany you. It's not loud. It's the absence of loud. And humans notice that. We're built to notice patterns, and the moon is one of the oldest. Its disappearance would be a distortion in the song we've always lived inside. Let's take it further. Imagine artists in the future trying to recreate night scenes. Without the moon, how do you capture that pale light that isn't really light at all, but reflection? How do you write metaphors for longing or distance without that luminous object hovering just out of reach? The moon has been a symbol of romance, madness, mystery, and transformation. Werewolves don't rise under streetlights. Lovers don't write sonnets to satellites. Without the moon, the tone of human imagination changes. Subtly, maybe, but deeply. And here's something worth noting, our relationship with the moon isn't symmetrical. We're fascinated by it. We write about it. We visit it. But the moon doesn't do any of that in return. It just orbits, silently, endlessly, reflecting light that isn't its own. A passive observer. Yet somehow, we imbue it with emotion. We assume it watches us back. What does that say about us? Maybe that we need watchers. Maybe that we need to feel seen by the universe. The moon fills that role nicely, visible, dependable, unchanged by the noise of our world. Its departure wouldn't just be the loss of a celestial body. It would feel like the universe turning away. Would we replace it? Maybe. We'd try to. Artificial moons are already being developed to reflect sunlight for energy or illumination. But those are functional. Cold. You can't write a lullaby to a metallic sphere launched by a corporation. Or maybe we'd pivot our myths elsewhere. Maybe Mars would become the new muse. Or Titan, with its methane seas. Or maybe the sky would feel emptier forever, and we'd have to build new metaphors from scratch. Either way, something breaks. Not loudly, not suddenly. But over time. A slow erosion of symbolism, ritual, and wonder. And here's the bittersweet part, we may be the only species on Earth that would notice. Dogs might miss the change in lighting. Owls might adjust their hunting. But only humans would ache for something lost. Only we would feel the emotional gravity alongside the physical one. That's the uniquely human burden, to be aware of absence. To look up at a blank sky and remember what used to be there. Now, let's leave Earth for a bit, not in imagination this time, but in the form of actual, dusty footprints. Because the moon isn't just a figure in our stories or a player in Earth's physics. It's also the only other place human beings have ever been. 12 people have walked on the moon. Just 12. All between 1969 and 1972. That's it. We sent machines farther. We've sent telescopes to the edge of the solar system. But in terms of human feet touching alien soil, the moon is it. Our one and only field trip beyond Earth. And that means something. Even if the moon had no other influence on tides or tilt or poetry, even if it were just a big rock, this fact alone would give it weight. Because it marks the boundary between what we have done and what we dream of doing. Think about what it took to get there. The Cold War. A global race. Rocket science invented practically from scratch. Human lives risked and sometimes lost. Billions of dollars. And for what? A flag. A few experiments. Some gray soil in boxes. But really, it was for something else, proof. Proof that we could leave. Proof that the sky isn't a wall. That we are not forever bound to Earth. And the moon was the first step. If it disappeared, or even just drifted so far that we could no longer reach it, it wouldn't just affect tides and seasons. It would change our trajectory. Because for a long time, space exploration has revolved around the moon as a kind of staging ground. A training field. A stepping stone. We test technologies there. We imagine moon bases, lunar colonies, as rehearsal for Mars or Europa or beyond. But without the moon, space gets harder. Not technically. We can still launch rockets. But psychologically. Strategically. Because there's something comforting about being able to look up and see your next destination. To know it's right there, glowing in the dark, waiting. Even if you're not ready to go yet, you can see it. And that keeps the dream alive. Now imagine it's gone. Where do you set your sights? Mars? Sure, but it's 20 times farther. A journey of months, not days. A place you can't see with the naked eye most nights. It becomes abstract. Distant. Less real. So the moon's presence does more than illuminate, it motivates. And in that way, its loss becomes a kind of anchorless drift. Like being on a road trip and realizing the next gas station is light years away. suddenly, you're less likely to continue. Or even to start. There's also something else. Something quieter. The moon missions gave us perspective. Not just of the moon, but of Earth. Remember the famous photograph, Earthrise? Taken by Apollo 8 as it rounded the moon and saw Earth peeking over the horizon, blue, fragile, alone. That single image changed the way we think about our planet. It inspired the environmental movement. It made us realize just how small and interconnected we are. No moon, no Earthrise. No Earthrise, maybe no sense of planetary responsibility. Maybe we continue polluting and dividing, thinking Earth is infinite. Without that distant reflection, we might forget how delicate it all is. And here's the emotional weight: every astronaut who went to the moon came back changed. They speak of the overview effect, a profound shift in consciousness when you see Earth from afar. Borders disappear. Petty problems dissolve. The planet becomes a shared home, not a set of separate nations. What happens if no one can experience that anymore? If future generations never have a destination close enough to trigger that perspective, do we lose something essential in our moral evolution? Possibly. Because the moon isn't just a place we reached, it's a place that showed us ourselves. And so, in thinking about its potential departure, we're not just mourning the loss of gravity or light. We're mourning the loss of reflection. Not in the mirror sense, but in the self-awareness sense. The moon, in its silence, helped us hear ourselves. Without it, we might become louder, but less thoughtful. More advanced, but less grounded. We might gain stars and lose our center. And in that quiet emptiness above, where once a dusty gray sphere reminded us of what we could do, we might find only darkness. Not the darkness of fear, but the darkness of forgetting. But let's return to Earth for a moment, not to the present, but to the deep past. Long before humans stared at the moon with questions or launched rockets at it with purpose. Let's go back to when Earth and Moon were practically strangers, still adjusting to each other's gravity, still forming their mutual rhythm. You see, the early Earth spun much faster than it does today. A day lasted only about 5 or 6 hours. Imagine that, 3 or 4 sunrises and sunsets in a single 24-hour stretch. It wasn't a peaceful planet. It was hot, volcanic, chaotic, and young. But the moon, closer and larger in the sky than you or I could imagine, was already tugging at Earth's edges. Through tidal friction, the moon began to slow Earth's spin. It's still doing that now. Just milliseconds per century, but enough to matter over eons. Today, our days are about 24 hours long. In the far future, they'll stretch even longer, maybe 40 or 60 hours, depending on what happens to the moon's orbit. This dance, Earth slowing, the moon drifting away, is what physicists call tidal locking in progress. It's a kind of gravitational negotiation. Earth gives up its spin speed, the moon takes that energy and moves outward. Eventually, if nothing else interferes, Earth will become tidally locked to the moon. That means the same side of Earth will always face the moon, just like the same side of the moon already always faces Earth. That future would be bizarre. A world where the moon hovers over one hemisphere, never rising or setting. The other side of Earth? Always moonless. But it might not get that far. Because other forces are at play, namely, the sun. As the moon moves outward, its orbit gets less stable. Far enough, and it may pass a threshold called the Hill sphere, the limit of Earth's gravitational dominance. Once it reaches that boundary, millions of kilometers away, the sun's gravity could overwhelm Earth's hold on the moon. And then? The moon would no longer orbit Earth. It wouldn't crash into us. It wouldn't vanish. It would simply become another object in its own solar orbit. A kind of X-moon. A rogue satellite turned minor planet. Still visible from Earth, perhaps, but no longer ours. This scenario would unfold over billions of years. We wouldn't notice it day to day. No dramatic breaking point. Just a long, slow unbinding. And maybe that's the saddest part of all, that you could lose something so fundamental and never feel it happening until it's too late. There would be consequences, of course. Earth's axis might start to wobble. Without the moon's stabilizing mass, our tilt could shift more drastically. Seasons would become unpredictable. Climates could swing wildly. The very predictability of life, the fact that summers follow springs, that oceans follow tides, might begin to unravel. That chaos wouldn't happen overnight. But gradually, generation by generation, we'd feel it. Not through catastrophic events, necessarily, but through the erosion of normalcy. Imagine future scientists trying to model Earth's climate without the moon. They'd see oddities. Long winters that weren't supposed to happen. Storm patterns bending in strange ways. Subtle tremors of instability building across centuries. And culture would evolve too. The moon's departure would become legend. Religion. Perhaps prophecy. Children would learn that Earth once had a twin in the sky. Artists would paint it into fantasy. Scientists would debate how real those stories were. And perhaps, thousands of years after it's gone, some child, looking through a telescope, would spot that pale dot in the distance and whisper, "That used to be ours." Maybe they'd send missions after it. Maybe they'd try to reclaim it, to bring it back, to build ships that could once again circle the moon like Apollo once did. But it wouldn't be the same. A recaptured moon wouldn't orbit naturally. It would need constant correction. Engines. Fuel. Maintenance. It would be like trying to relight a candle in a room with no oxygen. Because once a rhythm breaks, you can't always start the song again. Not the way it was. And yet, we'd probably try. Because the moon isn't just part of the system, it's part of us. Our earliest calendars followed it. Our oldest poems described it. It taught us the sky was moving. That time existed. That light could be reflected and change shape. That something unreachable could still feel near. So its absence would not just be physical or astronomical, it would be philosophical. It would raise questions about connection, permanence, and ownership. Can you lose something you never controlled? Can you mourn something that never belonged to you? Yes. Because belonging isn't always about control. Sometimes it's just about presence. And the moon has always been present. Even when we ignored it. Even when we cursed it for causing high tides or messing with our schedules or lighting up our telescopes at the wrong time. It was still there. What if one day, it wasn't? So let's follow that thought. Let's say the moon leaves us, not suddenly, not dramatically, but over millennia, inching its way into solar orbit until it's no longer bound to Earth. What would we, as a species, do with that reality? Would we adapt? Would we build new systems? Or would we, quietly, start trying to fill the void? Because humans don't like voids. Especially not in the sky. There's already precedent for this. Consider artificial satellites. The moon has always been our first satellite, but now we have thousands of others, metallic, human-made, purposeful. They orbit for communication, observation, defense, and even art. So what's stopping us from making a new moon? In fact, we've already begun. Several countries, like China, have explored the concept of an artificial moon, a reflective satellite that could orbit at a controlled altitude to bounce sunlight onto darkened cities. A kind of nightlight in the sky. Practical, maybe. Beautiful. Debatable. But let's stretch that further. Imagine an artificial structure launched to take the moon's place. Same orbit. Same apparent size. Same slow progression across the night sky. It wouldn't be a rock. It would be a machine. A carefully engineered device designed to simulate lunar behavior. Would it work? Technically, perhaps. It could reflect sunlight. It could follow a predictable path. It might even help regulate tides in some engineered form. But emotionally, culturally, that's where things break. Because the moon, as we've known it, isn't just a bright shape. It's layered with meaning. It's ancient. It's untouched. It's silent and irregular and full of craters made not by us, but by time and the solar system's violence. A machine can imitate light, but not history. It won't cast shadows with the same weight. It won't inspire folklore or superstition. It won't wax and wane with any mystery. It will simply exist, on schedule, maintained, lit when needed, dark when not. And that changes our relationship with the sky. Right now, when you look up, you're seeing something that predates language. A shape that our ancestors once carved into stone, sang about in rituals, used to navigate across deserts and oceans. It has scars from meteor impacts that happened before dinosaurs existed. It has no voice, but it has presence. A machine moon might glow, but it won't speak. And let's not forget, machines break. They need fuel. They need repairs. They degrade. The moon doesn't need us. It just is. And somehow, that's more comforting than anything we could design. Still, would we try? Absolutely. Humans hate losing things. Especially symbols. Especially parts of ourselves we didn't realize we were attached to until they were gone. So yes, we'd launch satellites. We'd design orbital arrays. Maybe we'd sculpt enormous mirrors or carbon structures. Maybe we'd even build a floating sculpture, a monument to the moon, made of stolen sunlight and tech ambition. But no matter how perfect it looks, it won't be the same. Here's where it gets more complicated. Suppose we succeed. Suppose we engineer a perfect replica, and after a few generations, no one remembers the difference. Kids are born into a world where the moon is manufactured. Its phases are programmed. Its orbit is managed by an AI that issues monthly updates. The tides respond predictably. Calendars still work. Romance novels still mention it. Have we won? Or have we replaced something true with something useful? That's a hard question. Because humans are great at survival. We adapt. We improvise. We engineer. But in that constant reshaping of the world, we often trade mystery for control. And the moon has always been about mystery. It's never really explained itself. It doesn't glow with intent. It reflects. That's all. But in that reflection, we've poured oceans of meaning. We've seen gods and omens and clocks and lovers. We've used it to measure crops and compose lullabies. We've landed there, and still, we stare at it with wonder. An artificial moon, no matter how accurate, may never invite the same gaze. And maybe that's fine. Maybe that's just evolution. Maybe wonder evolves too. Maybe future generations will look at their synthetic satellite and feel the same awe we felt looking at the real one. Maybe they'll write poems and songs and stories, and it won't matter that their muse is a machine. But maybe not. Maybe something will feel hollow. Not wrong, exactly. Just less. And that's the cost we pay when we lose things we didn't think we'd ever lose. Because when the moon is gone, we'll do what humans always do, we'll rebuild. But in the quiet spaces between invention and nostalgia, we might catch ourselves staring at a glowing orb in the sky and thinking, this isn't quite it. And then we'll look away. Imagine standing on a beach 1,000 years from now, looking up at the night sky. The stars are still there. Distant, sharp, indifferent. But the moon, your moon, is gone. Maybe there's a machine in its place, humming softly above. Maybe there's nothing at all. Just a darker sky and a strange absence you can't quite describe. And now think about how differently your ancestors would have felt, standing on that same beach 1,000 years ago. The moon was their constant. Their comfort. Their mystery. It guided tides and time. It lit the dark and made the night less lonely. Losing it wouldn't just alter science, it would alter meaning. That's the real ripple effect of cosmic change. Not the physics. Not the orbit. But the way we assign significance to the sky. The moon isn't just an object, it's a cultural anchor. Without it, what happens to all the things we used to attach to it? Start with language. So many of our words and phrases are moon-driven. Once in a blue moon. Over the moon. Moonlighting. Moonstruck. Shoot the moon. Pull that one rock out of the sky, and you're tugging at the threads of centuries of metaphors, songs, idioms, and dreams. Think about werewolves. Not just as monsters, but as cultural artifacts. The moon gave us transformation, change, madness. It shaped mythologies across continents. Ancient China believed in a rabbit on the moon, pounding the elixir of life. The Greeks tied lunar phases to the goddess Selene. Indigenous stories around the world placed creation, balance, and cycles in the hands of the moon. Remove it, and mythologies collapse. Or mutate. Future generations might grow up with hollowed-out stories, tales with missing pieces, riddles without moons. They'll ask why the old books keep mentioning it. They'll wonder what made people care so much about a rock. Even in religion, the moon played a role. It marked the Islamic calendar, guided Jewish festivals. It showed up in Christian symbolism, Hindu deities, and Buddhist texts. It wasn't always worshipped, but it was always there. A witness to prayers, a keeper of time. And now it's gone. Even if we had detailed historical records, even if we kept its memory alive through photos and simulations and documentaries, its absence would echo louder than its legacy. You can remember a friend, but that doesn't replace their presence. You can honor a tradition, but that doesn't restore its heart. Now let's step into art. Painters like Van Gogh and Caspar David Friedrich painted moons that glowed with more than just reflected sunlight. Poets like Sylvia Plath and Federico Garcia Lorca infused the moon with emotions they couldn't name. Musicians used it as metaphor, melancholy, mystery, longing. Would future artists still do the same? Maybe. But would it hit the same? Probably not. Because no matter how vivid the painting, no matter how beautiful the song, there's something different about seeing the real thing. Knowing that it's ancient, untouched. That the light on your skin tonight left the sun, hit the moon, and came down just for you. That kind of connection, real, physical, cosmic, isn't easy to replicate. And that brings us to a quiet question: how much of ourselves is shaped by the moon? Not in tides or tilt or biology, but in imagination. Think about how many childhoods were spent staring at it. How many lovers made promises under it. How many people across time, centuries apart, languages apart, shared that same silent companion in the sky? It's one of the few things we all had in common. The same moon over Cairo and Kyoto. Over the Arctic in the Amazon. Over pyramids and skyscrapers. Over war zones and weddings. It connected us. And without it, something gets lonelier. Not just the night sky, but the human experience. Because now, when you say I love you to the moon and back, it won't mean the same. When you read children a bedtime story that ends with "Goodnight Moon," they'll ask what that means. When someone says we're all under the same moon, you'll know it's no longer true. And maybe that's the greatest loss of all, the shared metaphor. The quiet thread tying us to each other through something bigger than ourselves. A cosmic lighthouse. A silver witness. A glowing reminder that, no matter how far apart we are, we're all looking up at the same sky. Until one day, we're not. Now let's take this one step further, because if the moon really did leave us, if it drifted out of reach forever, there's one final domain that would feel the tremor long after the tides shifted and the myths collapsed. And that domain is time itself. Because our concept of time, at least in its early forms, was lunar. Not solar. Not atomic. Lunar. Lunar calendars were the first timekeeping systems used by civilizations around the world, from Mesopotamians to Mayans to Chinese astronomers. They didn't use clocks. They didn't even use the sun. They looked up at the moon and watched it change shape. The moon gave rhythm to life. New moons marked beginnings. Full moons guided planting, gathering, celebrations. Whole months, literally months, were born from its cycle. And yes, the solar calendar eventually took over, but even now, traces of the moon remain in our timekeeping. The idea of a 28 to 31 day month is rooted in lunar phases. So is the ebb and flow of tradition, holidays, rituals. Lose the moon, and you don't just lose a celestial body. You lose the origin story of your own calendar, of your routine, of your cultural memory. Sure, modern society runs on seconds and GPS signals. But deeper than that, under the circuitry and timestamps, there's a shadow of lunar logic. A pulse. A slow, ancient beat. One that humans matched themselves to for thousands of years. So what happens to a species when it loses its first clock? Maybe not much, on the surface. Days still pass. Work weeks still drag. Alarm clocks still ring. But something goes unanchored. There's a difference between measuring time and feeling it. The moon helped us feel it. Its waxing and waning gave visual proof that time moved. That change happened. That nothing stayed still forever. Without it, we might keep counting, but forget what we're counting for. And let's talk psychology. Humans are deeply visual, deeply symbolic creatures. We respond to cycles. We need beginnings and endings, crescendos and rests. The moon gave us those naturally, gently, without needing to be explained. Its cycle paralleled our own. Think about this, every human who's ever lived, every single one, has seen the moon. Maybe not every night, maybe not always clearly, but it was always there. In childhood, in old age. During moments of joy, of loss, of wondering. It was a background constant. Its disappearance wouldn't just be noted in textbooks, it would be felt in the quiet hours. In the places we once expected to find it and now see only stars. It's like losing a familiar song you didn't know you were humming until it stopped. Would people adapt? Of course. That's what we do. But part of adaptation is mourning. Grieving the silent departures. The empty skies. And yes, science would go on. Astronomy would survive. Tides would recalibrate. But poetry? Poetry might falter. Because the moon wasn't just part of our physical orbit. It was part of our inner one too. Part of how we understood time, emotion, distance, connection. It gave shape to solitude. To longing. To imagination. Try writing a love letter without mentioning the moon. It's harder than you think. And this brings us to a deeper truth. The things we rely on most are often the ones we notice least. The moon never asked for our attention. It didn't blink or burn. It simply reflected. Quietly. Reliably. Night after night. And in doing so, it became one of the most profound symbols in human consciousness. Remove it, and we don't just lose a satellite, we lose a mirror. A quiet echo of ourselves. Our cycles. Our changes. Our impermanence. The moon taught us that beauty could be cold. That light could be borrowed. That distance didn't mean absence. Without it, we'd be left staring into a darker, more indifferent sky. Still vast. Still filled with stars. But missing the one thing that didn't burn or blink, just was. And maybe, in the end, that's the hardest lesson, that even constants can leave. Let's turn now to a more unsettling possibility, not just that the moon could drift away, but that we might actually be the cause of its departure. And before you roll your eyes and say, how could humanity possibly push the moon away, let's be clear, we're not talking about rockets or tethers. We're talking about the long game, the very long game. Because humans are now planetary engineers, whether we like it or not. We've terraformed parts of our own world already, even if unintentionally. We've changed the chemistry of the atmosphere, the temperature of oceans, the shape of coastlines. The idea that we might someday exert influence over lunar motion, directly or indirectly, isn't absurd. It's just unsettling. Picture this, future technologies evolve to the point where we harvest energy not just from the sun, but from gravitational forces. Tidal energy becomes dominant. We start building enormous tide-based generators, not just in a few countries, but globally, pulling more and more momentum from the moon's interaction with Earth. Remember how the moon is already moving away from us thanks to tidal friction? Well, if we started manipulating tides on a planetary scale, harvesting that push and pull, we could, in theory, accelerate that process. We could unknowingly, or even knowingly, cause the moon to slip further out of orbit faster than it would naturally. It wouldn't be catastrophic at first. In fact, the changes might seem beneficial. Stable energy. Predictable systems. Cleaner power. But over centuries, over thousands of years, that system would turn into a massive planetary scale lever, slowly pushing our moon away. By the time anyone noticed the long-term effects, the damage would be irreversible. The moon's orbit would be altered. Its influence weakened. Eventually, escape velocity could be reached, not from an explosion, but from a steady, gentle human-made shift. The irony? The moon would have left because of us, trying to make life easier. This isn't a guaranteed future. It's just plausible. And that's enough to ask, if we do reach that point, will we notice in time? Will we stop? Will we care? Because this wouldn't be like accidentally polluting a river or warming the air a few degrees. This would be an existential removal. A quiet erasure of the one thing that tethered us to the cosmos in a way nothing else ever has. Even worse, we might justify it. We'd say, well, energy security matters more than mythology. We'd write off the moon as an emotional loss, but not a strategic one. And that's where danger lives, not in malice, but in indifference. We already treat the sky like a landfill. Thousands of satellites. Debris clouds. Shattered rocket shells. If we ever get the capability to mine the moon or terraform it, the temptation would be immense. Rare materials. Strategic bases. Colonization projects. Each one would chip away at its identity. The moon would go from symbol to utility. From mysterious to monetized. And when that happens, we might not even need it anymore. We'd have artificial tidal systems, orbital light arrays, synthetic calendars. We'd explain it all in neat white papers and launch plans. We'd replace mystery with efficiency. Just like we always do. And yet, something essential would be gone. The moon has always been above us, not just in altitude, but in meaning. It was unreachable, unbought, untouched. The one thing that looked down on every king and criminal, every war and lullaby, with equal silence. To reduce it to a project, a resource, a liability, would be to lose a piece of humility we didn't even know we had. We've stared at it for tens of thousands of years and never once heard it speak. And still, we listened. If we make it vanish, whether by neglect, ambition, or design, we won't just miss its light. We'll miss its silence. And in that silence, we'll hear ourselves echoing back a little too loudly. Let's imagine the end. Not the explosive kind, not the sudden catastrophic loss of the moon ripped from orbit, but something slower. More insidious. A quiet fade, like a song played lower each night until you're not sure if it was ever there at all. The moon continues to drift away, millimeter by millimeter, century after century. No great alarms. No global headlines. Just distance accumulating, unnoticed, like dust on a shelf. Generations pass, and the moon seems smaller, colder, more remote. Still visible, but a little less real. One day, someone looks up and doesn't see it at all. Maybe it's behind the clouds. Maybe it's a new moon. Maybe it's gone. They check the sky again the next night. Nothing. A week later, still nothing. The calendar says there should be a full moon, but the sky is empty. Only stars remain, unblinking. And that's when people begin to realize, the moon has left us. No explosion, no betrayal, just absence. At first, the world reacts with disbelief. Scientists scramble for explanations, tracking orbital data, comparing old observations. Historians and theologians argue about what it means. News anchors cycle through phrases like unprecedented event and cosmic mystery. But then reality settles in, it's not coming back. And things begin to change. The tides, already strange for decades, become erratic. Coastal cities re-engineer their barriers. Fishermen abandon traditions passed down for generations. Marine ecosystems shift. Animal migrations fail. Beaches rot. Culturally, it's worse. Poems feel hollow. Old songs feel naive. Lunar holidays vanish from calendars. The term once in a blue moon becomes obsolete. Children ask, why do people say that? And adults stumble to explain something they themselves don't fully remember anymore. Religions that once used lunar phases to track sacred time lose part of their rhythm. A few rewrite their doctrines. Others refuse to change, their rituals slowly drifting out of sync with reality. Worse still is the psychological impact. People start sleeping poorly. Not because of tides or light, but because of something missing. The night feels deeper now. More empty. Like a room with the door permanently left open. Insomniacs stare at the stars and feel a vertigo they can't name. Artists try to recreate the moon in VR, in paintings, in stories. But none of it feels the same. You can't simulate a heartbeat, and the moon was always more than a rock, it was a rhythm. Space agencies debate a lunar replacement. A giant satellite array to mimic its mass and light. An orbital lighthouse. It's technically possible. But emotionally impossible. Because no matter how perfect the reconstruction, everyone knows it's artificial. A lie in the sky. A placeholder for something sacred and accidental. Eventually, people adjust. Of course they do. New metaphors arise. New myths. Children born after the disappearance don't miss what they never knew. To them, stories about the moon are just that, stories. Like dragons. Like Atlantis. Like the idea that you could once fall in love under its glow and feel, somehow, understood. But for those who remember, the sky never feels the same. Because losing the moon isn't just about physics. It's about losing the one thing in the universe that made night feel human. Not hostile. Not cold. Just distant in a familiar way. Now, the stars look sharper. Colder. More foreign. Beautiful, yes, but in the way glass is beautiful, hard, breakable, untouchable. The night becomes a place of silence without warmth. Still filled with wonder, but lacking a witness. And that's what the moon always was, a witness. To our history. To our mistakes. To our love stories and bad decisions and quiet moments on porches and battlefields and rooftops. It never judged. It never spoke. It just was. And now, it isn't. Which leaves us with this: what else will we lose before we realize what mattered? What other constant will vanish while we're too busy chasing the next shiny thing? Because the moon taught us that beauty can be borrowed. That light can come from reflection. That closeness isn't always necessary for connection. And now that it's gone, maybe we finally understand what it gave us. Not tides. Not time. But something harder to name, and even harder to replace. And so here we are, standing under a darker sky, a little quieter than before. The moon is gone, and in its absence, we've discovered just how much it meant. Not just to science, not just to tides or calendars, but to us. To being human. Because the moon was more than an object. It was a presence. A quiet reassurance that even when the world felt chaotic, something constant would rise in the night. And without it, the darkness feels deeper, not terrifying, just emptier. Now we measure time by new tools. We track the sea with sensors. We tell stories without the glow of that ancient silver eye. But none of it quite fills the gap. None of it stands in as a true replacement. Because the moon didn't just orbit Earth, it orbited our imaginations. And that's the real loss. Still, we adapt. We always do. Our species is good at building new meanings. We'll find new ways to mark the passage of time, new myths to tell, new lights to chase. But every so often, maybe while staring up from a rooftop or walking home alone, you'll feel it. The emptiness. The quiet. The place in the sky where something used to be. And maybe that will be enough. A reminder. A whisper of what was. So wherever you are, whenever you're listening, thank you for taking this slow journey through loss, wonder, and change. If it helped you sleep, or think, or feel even a little less alone under a quieter sky, then it was worth it. Until next time, explorer. Sweet dreams.